Okay, so does it have graphing on it? Oh, now I need to look. Oh yeah, there is. Never mind. Okay. So today we are doing quadratic transformations. We're not actually like identifying any transformations. So what we are doing is we're taking a generic quadratic and we are finding the vertex form of it, which allows us to graph it and identify graphical characteristics a lot more easily, okay? So on the first ones, or the first few examples, we're just going to be changing a quadratic equation into vertex form and then going from there, okay? In order to do that, we have to remember what the vertex form of a quadratic is. And the vertex form of a quadratic is of the form y minus k, I don't know why I put plus, equals a times x minus h squared, where our vertex has the coordinates h, k. In order to get to vertex form, we're going to have to use our completing the square skill that we learned a couple classes ago, okay? So we're going to be using that to form a vertex form of a quadratic. So the first example that we're going to go ahead and start with is the quadratic y equals x squared minus 4x minus 21. For this example, not only do I want to put it in vertex form, but I would also like to identify the x coordinates and the the x intercepts and the y intercepts of the parabola. So let's go ahead and do that. The first thing I need to do is I need to get this in vertex form, which means I'm going to have to complete the square. So I'm going to move this 21 over to the left-hand side. I'm going to look to see if there's a number in front of my x squared. If there is, I need to divide it out. There wasn't any, so I didn't have to do that. From here, I'm going to do the completing the square portion, which means I'm going to take this x term, I'm going to divide it in half, and I'm going to square its answer. So negative 4 divided by 2 is negative 2. Negative 2 squared is a positive 4. What I do to one side, I have to do to the other. So now I have y plus 25 equals x squared minus 4x plus 4. I know that right side is a perfect square trinomial, which means I can factor it very easily. And it factors into x minus 2 times x minus 2, which I can then rewrite as x minus 2 squared. So now I've transformed this quadratic into the vertex form of y plus 25 equals the quantity x minus 2 squared. Now that I have this in vertex form, it's very easy for me to identify what the vertex of my parabola is. So the vertex is the opposite sign of the number attached to my x and the opposite sign of the number attached to my y. So the vertex of my parabola is 2, negative 25. Anybody confused about how I got my vertex or put it into vertex form? Okay, so the next thing I'd like to find are the x-intercepts for this quadratic. We could, of course, come back to this original equation, and then we could factor it or do the quadratic formula or something like that. Or we could do something a little bit easier. Since I have this vertex form, I can take that and since I'm trying to find the x-intercepts, I could replace the y with a 0. And then solve for x. So on the left-hand side, 0 plus 25 is just 25. So I have 25 equals the quantity x minus 2 squared. I would like to solve for x, so I need to square root both sides. A square root and a square cancel each other out, which leaves me with the square root of 25 on the left-hand side. We have to do the positive and the negative versions. So I have positive negative 5 equals x minus 2. I'm going to go ahead and add the 2 over. So I get x is equal to 2 plus and minus 5. Split that into my 2 problems. So 2 plus 5 is 7. 2 minus 5 is negative 3. So my x-intercepts are the points negative 3, 0, and 7, 0. So now I found the vertex and I found the x-intercepts, but I still need to find my y-intercepts. The same kind of process is used to find our y-intercept, except instead of putting a 0 in for y, I'm going to put a 0 in for x. So now I'm going to have y plus 25 equals 0 minus 2 squared. Simplify what's inside the parentheses. 0 minus 2 is just negative 2. When I square negative 2, I get 4. And then I subtract the 25 over. And when I do, I get y equals a negative 21. I would write that y-intercept then as 0, negative 21. When you write your answers, I would prefer if you put them all in one spot, just so it's a little bit easier for me to find. And then you're done. Any questions, concerns, or issues with this? So all we did was we transformed it into vertex form. We identified our vertex, we identified our x-intercepts, and we identified our y-intercept. Anybody have any major issues with those things? That's all we're doing for the first part. So we're going to do another example just to make sure you really have it cemented in your brain. And then we're going to kind of add in the graphing component as a nice little review. Okay, so if there are no other issues, we're going to go ahead and do another example. And then we'll move on to the graphing component of it. Let me pick a really good example. Okay. So this time, I'm I'm going to do the same thing. So I need to transform it into vertex form, identify the vertex, identify the x-intercepts, and identify the y-intercept. So this time I'm starting with the quadratic. Y equals -1/2 x squared minus 8x plus 14. Okay, so from here, I want to go ahead and move the constant over to the left-hand side. So when I do that, I get y minus 14, and then I have equals -1/2 x squared minus 8x. From here then, I would like to go ahead and take out a common factor from these two terms. So on this one, I have that -1/2 in front of my x squared. So I need to take that -1/2 out of everything. In order to do that, I'm going to, actually I want to do this a little bit differently to make it a little easier for you. Instead of factoring it out of this, I think I want to get it out of all of my terms, just so I don't have to deal with it right now. So what's the opposite of dividing by 1/2? Or -1/2, sorry. It would be to multiply everything by -2. So let's go ahead and do that. When I do that, I get -2y plus 28 equals x squared plus 16x. And now I have nothing in front of my x squared. Eventually it's going to have to come back, but for right now we're good to go. Which allows me to go ahead and complete the square on that right-hand side. To complete the square, I go to my x term, I split it in half, and then I square my answer. 16 divided by 2 is 8. 8 squared is 64. So I'm going to add 64 to both sides of my equal sign. I can go ahead and simplify the left. I have -2y plus 92 equals, on the right-hand side, I can go ahead and factor it. This factors into x plus 8 times x plus 8. I can go ahead and rewrite that right-hand side as x plus 8 squared. On the left, I still have the -2y plus 92. This is almost in vertex form, but it's not quite. My y has to not have a number attached to it. So remember when I multiplied everything by -2 to get my x squared with no number in front of it? I now have to do the opposite to get my y so that it's alone. So the opposite of multiplying everything by -2 is to divide everything by -2. And by everything, I mean all terms. -2 divided by -2 cancels out. 92 divided by -2 is -46. And then the right-hand side, I would just write as -1/2 times that parentheses. And now I am in vertex form. Which means, that it's very easy for me to identify what my vertex is, correct? because my vertex is the opposite sign of the number attached to x and the opposite sign of the number attached to y, which means my vertex here is -8, 46. After identifying the vertex, I can go ahead and calculate my x-intercepts and my y-intercept. We'll start with the x-intercept. To find the x-intercept, I put 0 in for y and then solve. So I'm going to have 0 minus 46 equals -1/2 times x plus 8 squared. The 0 minus 46 just means I have -46 on the left. I would like to solve for x, so I need to move this -1/2 to the other side. When I do, it's the same as multiplying by -2, which leaves me with a positive 92 equals the quantity x plus 8 squared. I need to square root both sides to get rid of the square on the right. So I have positive negative square root of 92 equals x plus 8. I need to subtract the 8 over, so the x is by itself. When I do that, I have -8 plus or minus the square root of 92 equals x. However, I'm not finished because I'm pretty sure I can take a perfect square out of 92. After going through my list, it's pretty obvious to me that I can take a 4 out. And the square root of 4 is 2. Which leaves me with -8 plus or minus 2 times the square root of 23 equals x. And then I separate it into my two terms, and I'm done. So my two x-intercepts are -8 minus 2 root 23, 0, and -8 plus 2 root 23, 0. So they're not always going to come out to nice, pretty numbers. We found our vertex and we found our x-intercepts. So I still have to find my y-intercept. The way I can do this is I can plug 0 in for x and solve it out. So that's what we're going to do. So when I plug 0 in for x, I get y minus 46 equals -1/2 times 0 plus 8 is still just 8 squared. 8 squared is 64 times a -1/2 is a -32. So I have y minus 46 equals a -32. I go ahead and I add the 46 over, and I get y equals 14. So my y-intercept is 0, 14. And then we are done with that problem. I will tell you a shortcut to finding your y-intercept, however, in case you didn't already figure it out. Your y-intercept is simply the constant on the end of your original quadratic equation. So whenever it's written out expanded like this, whatever number is on the end that doesn't have a variable with it is your y-intercept. So that could save you, on this one, a very small chunk of time, but still. Any questions, concerns, or issues on changing to vertex form, finding your x-intercepts, finding your y-intercepts, and then of course identifying what your vertex is? Okay, so let's move into the graphing component of this. You've already graphed before, so it's not going to be a whole lot of extra work. So there are two ways that we can graph in a parabola, or the two best ways. One, if it's an expanded form, we can do the negative b over 2a and then plug that number back in and find our vertex. Or we can change it into vertex form, identify our vertex and our line of symmetry, and then plot our y-intercept and its matching point, and we're done. This is the way I'd like you to do it on your homework. Okay, it's probably already set up even in vertex form for you, at least on some of them, so it makes it a lot easier. Okay, so for this example, we're going to graph it after turning it into vertex form. My equation is y equals 4x squared minus 16x minus 40 right off the bat. I know I'm going to go ahead and move the 40 over with the y. I have a number in front of my x squared, so I need to get rid of that. The only way to get rid of a 4 being multiplied in is to divide it out or multiply by 1 over that number. So I'm going to multiply everything by 1 over 4, or you can think of it as dividing 4 out of everything. When I do that, I'm left with 1/4 y plus 10 equals x squared minus 4x. Now there's no number attached to my x squared, so I can complete the square on that right-hand side. So I take my x term, I split it in half, and I square the answer. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. What I do to one side, I also have to do to the other side, which leaves me with 1/4 y plus 14 equals x squared minus 4x plus 4. I can factor that right-hand side into x minus 2 times x minus 2, which is the same as x minus 2 squared. On the left-hand side, I have the 1/4 y and the 14. Sorry, I'm just making sure I wrote the right one. So what I'm going to do now, because I need the y by itself, is I need to multiply everything in here by 4. 1/4 y times 4 is y. 14 times 4 is 56. And then I'm multiplying 4 into that entire function on the right, which means I'm just putting the 4 out front. And now I'm in vertex form. From here, I can just go ahead and identify my vertex. So again, the vertex is the number attached to x, but the opposite sign, so 2, and the number attached to y, but the opposite sign, which is negative 56. The x-coordinate of my vertex is also my axis or my line of symmetry. Okay, so I already have 2 parts of my graph just from finding that vertex. So that's what I'm going to go ahead and do next, is graph it. So I know my line of symmetry goes through x equals 2, because that was the x-coordinate of my vertex. I'm going to count by 5s coming down. Okay, I did not space that very well, but the bottom one is 55. I'm going to go ahead and plot my vertex, which was 2, negative 56, which is about right here. I also already know another point from my graph, right? Because I was given the original equation, I know what the y-intercept is, and it's negative 40. So I go to negative 40, and I go ahead and put a dot. I also find its match on the other side of my line of symmetry, which gives me 3 points. When we graph our quadratics, we need 5 points in total. So to find my next point, I can just go ahead and take x equals 1, plug it in for x here in this vertex form equation. When I do that, I get y plus 56 equals 4 times 1 minus 2 is negative 1. When I square negative 1, it's just 1. And 1 times 4 is just 4. Subtract the 56 across, and I get y equals negative 52. So the next point I can graph is 1, negative 52, which is going to be about right here. Find its match on the other side, and I have my 5 points. So once you have those, you can go ahead and draw your parabola, and you are good to go. Any major questions, concerns, or issues with those?
Mr. I was just about to ask that question.
You do not always have to find your x-intercepts. When you're graphing, unless I'm asking specifically for those, you can use any 5 points on the graph. It just so happens when we did these previously, we were so close to the x-axis that we found them by default. So you do not necessarily need them to graph it, no. I'm never going to say no, though, if you wanted to find them. Do we have any other major issues with this? Do we need to see another example, or are you guys okay? Because I know we've done graphing before, so I don't want to give you examples that you don't need. Would anybody like to see another example? Okay. There are plenty more examples in the notes that are on Canvas. As always, you're more than welcome to look at those. I actually have a ton on there. So feel free to look at those, work through them if you would like the additional practice. If not, the homework is on Canvas. There is graphing on it. I did look. I apologize. I made it several days ago. So you can go ahead and get started on that. I will remain on this Google call, of course, until the end of class. If you have questions outside of that, please feel free to email me. Okay, any other questions before I let you go work on that? Okay, well, I guess have a wonderful day. If you need help, I will be on this Google call.
Hey, Mr. Ann.
Yeah, what's up?
By the way, impromptu is the...
I figured that's what you were doing again.
All right.